All right, this is section 10.1, and today we're going to start talking about three-dimensional space. We start off this whole unit by just talking about how to graph in three-dimensional space, and then eventually we're going to use it to talk about vectors in 3D space. So the three-dimensional coordinate system looks like this, with x kind of coming out of the board at you, y going left to right, and then z going up and down. So the x-axis is front to back, the y-axis is left to right, and the z-axis is up and down. What I drew so far are all the positive axes. The negative ones are the dotted lines. So x would kind of go back into the board, y would go to the left, and z would go down. And hopefully, I guess the hardest part for kids is to see this in 3D, but hopefully you see the x's coming out of the paper at you. Something that does help some students when they're drawing these is to think of when you were little and used to draw these 3D cubes all the time. And that's essentially what we're doing. We're just focused right now on three of the axes, three of the sides. And now we're going to talk about how to plot them. So when you were little and I asked you to plot the point 3, 4, this is a path you are taking. You went to the right 3 and then you went up 4 and you put a dot. You followed the path to that dot. We're going to do the same thing here. This is x and then y and then z, and you have to use them in succession. So after you travel 3, then you're going to travel 7, then you're going to travel 3 more. So this is not, and this is sometimes what kids do, is if I say plot 3, 4, 1, 2, 3, 1, 2, 3, 4, and then I will have students just connect these. Remember that we are plotting a point, so in the end I should end up with a dot, not a line. So 3 first, this is the x-axis, y, and then z. So x is coming out of the board at you, and since you can't really see those tick marks on my paper, I'm just going to make my own to make it a little bigger. So 1, 2, 3. Then I'm going 7 to the right on the y. 1, 2, 3, 4, 5, 6, 7. So the path so far is out 3 and then over 7. So I'm about right there-ish. So hopefully you can see that as kind of a parallelogram sitting on that flat surface. And now I'm going to go up 3. 3 technically is right there, but I can't go up that high because that's not in proportion. If I say this is 3, I can't go all the way up there for 3. This amount of 3 has to be the same as down here. So my 3 is probably about right there. This is all you have to graph me when you are doing these on the test. You have to be able to show me the path that you took. So this is about the bare minimum. Some students do find it helpful to draw that cube that they've been drawing since they were young. And then once they have that cube drawn, they can go, I want that corner because I came out 3, over 7, and then up 3. And so that's a little easier for some people to be able to draw. Next up is -2, which means it goes back into the board 2. Then I'm going -8 to the left. So I'm way out there, out about that far. So hopefully you can see that this is kind of in the back corner. And then I'm supposed to go 3 from there. So I'm going to go up 3 from there. I can't go this 3. I can't drop it way down to here. I have to have some height. And remember that this 3 has to be the same amount as that 3. So I'm kind of just raising it up in the back corner. If it helps to draw, those cubes, again, that you were drawing as a kid, do that. And then just circle the corner. That's the corner I'm after. Last one, -4 goes into the back 4, to the right 4. So now I'm kind of in that back corner. And then I'm supposed to go down 1. So it's just kind of hanging there off the back end of that little box. Distance formula is the same as it was in 2D. All you're doing now is just adding that third dimension of z. So it's still x2 minus x1. y2 minus y1, and then z2 minus z1. So not really a big change there. You're just adding on that extra coordinate, like I said. So 5 minus 2, 6 minus 4, and 2 minus a -1. Gives me 3 squared, 2 squared, and 3 squared. So I've got 9 and 9, 18, and then 4 more gives me the square root of 22. Midpoint formula, again, it's the same as it was in 2D. You're just going to add on an extra variable. So x2 plus x1, y2 plus y1, and z2 plus z1. So just add them all up and dividing in half. So 6 plus 2 is 8, 0 plus -3 is -3, and 3 plus 1 is 4. So in the end, I end up with 4, -1.5, and 2. Remember, this is a midpoint. So I should end up with a point in the end, an x, a y, and a z. Next up, we're going to talk about the equation of a sphere. When you were a sophomore, you learned that the equation of a circle looks like this. And we kind of stopped there, and it was equal to r squared on the other end for your radius. And now that we've moved into 3-dimension, all we have to do really is the same as anything else. We just have to add in our last term, which in this case is a j. Your center of your circle is the h, the j, and the k. The x, the y, and the z, those are your variables. Those stay in the equation. You don't put anything in for those. The h, the k, and the j are what your center is, the center of your sphere. And it's always the opposite of what's in parentheses. So if you have a +1, then you're going to pull out a -1. And then you have a radius on the other end, and that too is squared. So let's write an equation of a sphere with this for the center and that for the radius. There's no real math to do. All you're doing is plugging these numbers in. Again, you do the opposite. So if I have a +2, then I have to have a -2 in parentheses. If I have a -3, then I have to have a +3. And if I have a +1, then I have to have a -1. You don't have to FOIL this. We don't simplify. We don't solve. That is literally how we leave it. You could change the 5 squared into 25 if you wanted, but this is just fine. Next off, if I gave you the equation, could you pull out the center? So you just do the opposite of what's in parentheses. -1, a +4, and z has nothing with it, so that's a 0. And then your radius is not 49, it's 7, because you need to root it. Those are all nice and easy as long as you have the equation all factored out for you. What happens if you get it and it's not factored? This is one example where while you're writing down the math, you're going to be wanting to write down some words to remember what happened. So first step is I'm going to put all the common letters together. Everybody's going to get together with their partner. I'm going to leave a little bit of space because I'm going to need that for the next step. So putting every variable together with its match, and then anything without a variable gets moved to the other side, and algebraically moved, so I had to add the 2 to the other side. Now what was really nice up here is these guys were all factored, and if they're factored, that means that they originally looked something like that. And then I just have the factored form. And anytime you want to factor, you need those 3 terms to do it. What sucks here is I've only got 2, which means I'm missing my 3rd term. So I need to create that. I need to find out what that 3rd thing is. So we're going to do something called completing the square. I want it to be a very particular term so that when I get done, I have something squared and something squared, which means that when I go to factor these, I have to get the exact same thing in both parentheses. I would have to get y minus 4 and y minus 4, so I can write y minus 4 squared. So I'm creating something right here so that those 2 factors come out to be the exact same thing, so they come out perfect. So doing a completing the square problem, you take the b value, you divide it by 2, and you square it. So -2 divided by 2 is -1. You square it, that's a 1. That will provide me with a perfect square so that when I factor it, I get 2 of the same thing. Taking 6 divided by 2 and square it gives me 9. Taking -4 divided by 2 and square it gives me 4. And this is a balanced equation. So when I decided to add 1 to this side, I also have to add 1 over here to keep it balanced. If I'm going to add 9, I have to add 9, and same with the 4. You can add whatever you'd like, or subtract for that matter, but what you do to one side, you have to do to the other. And it's not moving this 4 over. I'm not subtracting this 4, but I added 4 to this side. I have to add 4 to this side. So now we just need to factor it, and we are almost home free. In order to factor this, if you enjoy factoring, go ahead and work it out off to the side. Another little trick about completing the square is it kind of gives you what your factor is. When you take your b divided by 2, so your -2 divided by 2 and get -1, that's actually your factor. When you square it, that's the number that goes up there. So 6 divided by 2 is 3, but when you squared it, that's what number went up there. -4 divided by 2 is negative. Whoops, I need a z first. And then when you squared it, that's what went up there. So squaring it gives you the line on the blank, which also gives you your other side. And then when you just divide it, that actually tells you what's in your factor. 2 plus 1 plus 9 plus 4 is actually 16. So now we can take our center right out, which is 1, -3, and 2. And our radius is 4. If you need to, I highly suggest you go back and watch that part again, writing lots of words about what we did. We first grouped all of our variables. Anything without a variable moved to the other side. We drew our 3rd blank. We completed the square, dividing by 2 and squaring it to fill our blank. Those numbers went on the other side as well. We factored, and then we pulled out the center.